Now that I've given you an overview of how this application is designed, the PrimeCheck app case study, let's talk a bit about the server-side structure and functionality. So that's this piece here. Again, you can get that from the EX1 folder in my web MVC repository in live lessons. So we'll first start by taking a look at the design of the PC for PrimeChecker server controller class. And you can see that this is the class. We make it a REST controller. Remember, that's that annotation that can be added so that Spring knows about this. It can implement the inversion of control feature. And an instance of this will be registered with the Spring framework so that when requests come in from clients that have the appropriate GET information in the GET request, we can go and dispatch things to these methods. These are the actual methods. By the way, it's worth noting, except for my test cases for my programming assignments, it doesn't really matter what these names are. Be careful of that, by the way. The test cases kind of have some expectations on the way that these methods are named. But in general, if we weren't trying to test stuff in using white box testing, you could call this whatever you want. It's not important, really, what these names are. It's important what these names are. So here you can see that we take a strategy and in this case, an integer. Down here you can see we take a strategy and a list of integers and also a flag that indicates whether we want this computation to run in parallel or not. And all these methods do is they just forward on to the strategy. As a general rule of thumb, keep your controller methods as simple as possible. Just kind of forward them, whatever minor tweaks you need to make to get them into the right native format. That's about all you want to do there. That was also a frequently made mistake from the first assignment. People weren't using request param properly, and we'll talk about that in a second. We have the get mapping, which says these guys are now endpoint handler methods. That means they're going to be dispatched when URLs come in with the appropriate route name. This is the route name. Again, I probably should have been more abstract and used constants here as opposed, string constants as opposed to string literals, but do it the right way. This is just kind of make it easier to tell what's going on. So these would normally be in some kind of constants file that would be shared between client and server to avoid getting things out of sync. This annotation says this is a list of something. Very important to know how to use this. A few people got this wrong in their implementation of assignment 1. Please make sure for assignment 1B that you get this right. This is what's going to allow the information to be treated as a list when it shows up. So Spring will automatically take the part of the get URL or URI that comes in, and if it's something that's designated to be a request parameter that's a list, it'll break it up and put it into a list. So you get a list, not a string, which is a nice improvement it does for you out of the box. So let's talk about the service. Once again, we annotate it with service. That's always important. If you forget this, then Spring won't know how to do all the other magic, like doing auto wiring and dependency injection and so on. It can also do other kinds of things with the service annotation on a class. Here's what we use as our data structure. This also looks very familiar to the bearer quotes example. We have an array of different strategies where the order matters. So we have 0, 1, and 2 being structured concurrency, parallel streams, and completable futures. We could also have implemented this solution using multiple microservices. I will show you that soon. Trying to keep it simple so we don't have to talk about that yet. That opens up a new can of worms, especially for testing. But for now, keeping it simple. And you can see here that we have a method called checkIfPrime, which checks the primality of a single integer. We take the strategy and the prime candidate, and we index into that array that we defined back over here, get the designated strategy, and then we call its checkIfPrime method, passing in the prime candidate. Pretty simple. Remember the pros and cons of this approach. It's very efficient because we're just indexing into an array, but if you give a strategy that is not what you expect or it's out of the range, then some index out of bounds exception will be thrown here, and that'll be confusing to the caller. Here's the other method. This is checkIfPrimeList. As the name suggests, it takes a strategy and a list of prime candidates, and you'll also notice it's going to return a list of results. Each item will match. If you give it one thing, it'll give you back whether it's prime or not. And you can also see here that we take a parameter that says whether or not we're going to be using parallel or sequential processing. Once again, we index in, find the strategy, make the call on the strategy object, passing in the prime candidates list, and whether we want things to run in parallel. Now we're getting into the actual implementation. This is where the rubber hits the road. We're actually going to do something that's computational, not just connecting the pieces together using controllers and services. So this is the PC abstract strategy class, which is going to, as you can see, have a default implementation of isPrime, because there's really only one way to do this. So you can see that we make this an interface. And this is important to remember. This is a little different with modern Java versus classic Java. So in classic Java, interfaces could not have method implementations. They could only define method declarations or signatures. With modern Java, Java 8 and beyond, now you can have so-called default implementations. So this is the default implementation. You can read more about that here. And that is intended to be used by anybody who doesn't want to make any changes to it, and there's no reason to make changes to it by any of the other strategies, so we give a default result implementation here. This method, because this is an interface, is just a declaration. It's just a signature. And the different implementations of this interface, like parallel strategy, stream strategy, the one that does structured concurrency, the one that does completable future, et cetera, they're going to override and implement this method. So we just leave it here as kind of a placeholder for later customization. Oh yeah, great question. So the question is, what would happen if we were to try to make an implementation of an interface, sorry, an implementation of a method in an interface, and we didn't put default? It should be a compile error, because you have to specifically indicate, hey, I know this is an interface, and normally interfaces only have signatures or declarations. This is going to be a default implementation. So by putting the word default, it's a flag to the compiler. I really know what I'm doing. Take me at my word. I really want to make this the implementation. That's the default implementation. So the question was, is this similar to C++, where you can have default constructors? In C++, the default constructor will do member-wise initialization of the fields. So there's a default set of things. In this case, default says, I'm actually going to provide an implementation. So default constructors in C++ say, I'm not going to provide an implementation, but you know what to do, compiler, because you know how to do member-wise initialization of the fields, the data members. In this case, we're like, hey, this is the default implementation. So we're explicitly giving it an implementation. That's right. The way to look at this is it's saying, if the implementation of this interface doesn't override this method, here's what I want you to use for the default. That's the way to look at it. So check if prime, we talked about that. So that's the end of the overview of the server structure and functionality.